All right, now we're extending factoring into factoring trinomials where there is a coefficient for the x squared term other than 1. All right, so lots of interesting work has to happen here. And I have a method I like to refer to as smiley face, and you'll see why in a minute. So the first thing that I notice is that the first term in this expression is 5x squared. So over here I'm going to say 5, and then I'm going to put all the pairs that multiply to 5. Well, it's only one pair. The next thing I notice is that my last term, notice I underlined it twice, is in a different color, is a 2. So 2, and the only option for that is 1 and 2. So now I have to still have my two sets of parentheses, but you want to give yourself a little more room this time. You don't want them real tight. Your variable is x, but you're going to leave a little room for it in front of the x in both cases. You have signs of a minus and a minus, which means we're going to use 1 plus and 1 minus. Now you might not have them plus minus, you might have them minus plus. It doesn't really matter. What really matters is how the other numbers fit in there. I need a pair of numbers that multiply to give me 5, that go next to here to give me 5x squared. And I need a pair of numbers that multiply to give me 2, that go here and here. And then here's where the smiley face part comes in. To check for the middle term, as long as I put a pair from the red here and a pair from the blue here, I'm going to get my first and last term. But to get my middle term, I have to multiply these two together, get an answer, multiply these two together, get an answer, and then add them up to see if they come out to my middle term. Now, will we put them in the right place the first time? You can possibly do that, but not always. So I'm going to do 1 and 5, and I'm just picking where they go. I'm going to do 2 and 1. Just see how that comes out. So when I do that, 2 times 5 is 10x. 1x times negative 1 is negative 1x. And when I add them up, I get 9x. That's not what we were looking for. So we need to do something different. All right, so I think what I'm going to do, I'll move that over there just to get it out of my way. I want to get a negative 3x. So let's just pick a pair to switch places. You have to only pick either the single with the single or the double with the double. You can't pick a single and a double and switch places, because that's going to mess up your first and last term, even if it gives you your middle term. So when you're done, check it. Make sure that you haven't made any of those mistakes. Let's pick the 1 and the 2 to switch places. So is that what I wanted to do? Yes. All right. So now I'm going to check this. 5x, negative 2x. Does that give me negative 3x? No, it gives me positive 3x. Well, if you get the right number, wrong sign, and everything else is good, just switch the signs. Now, it's nice to do that on a smartboard. I know you can't do that in your notebook as easily. That's why you should really use a pencil with an eraser when you're doing factoring. Now that I've done that, now I've got a negative 5x, a positive 2x, and that gives me a negative 3x, and that's what I was looking for. So you can see these, sometimes you're going to get the answer like that. Some people are really good at that. Other times you're going to have to really work at it and try all the pairs before you find the right one. Kind of like looking for a lost pair of keys or something like that. It's always in the last place you look, and I hope you stop looking after that. All right, so let's try this one. pair of numbers, so two sets of parentheses, right? X, X, signs tell me plus and plus, and I need a pair of numbers that multiply to 12, that go here and here. I've got 12, 1 and 12, 2 and 6, 3 and 4. And then I need a pair of numbers that give me 35, that are going here and here. 35, 1 and 35, 5 and 7. Okay. And we're going to go for the smiley face to check our middle term. Now you could just start plugging numbers in, plug and chug, and see if you can come up with 52. Now in the last one, there was a plus and a minus in here, but this time they're both the same sign. So we know it's definitely to add to get to that number, so it's a little easier. My suggestion, especially for Honors Algebra 2 students, is when you're trying to do this, try the pointing method. You can still do what we did last time. Pick a pair from this one, pick a pair from that one, plug them in, see if they work. If they don't, swap a pair, see if that works. If that doesn't work, take out a pair and replace it with a different pair for that number. There's a much easier way to do that though. If you're good with your multiplication tables and you can keep numbers in your head or write them down to help you. And here it is. And by the way, I always start with the ones that are closest together in number. Like 2 and 6 is further apart than 3 and 4. So I always start with the ones that are closest together and I work my way to the ones that are further apart. Because more times than not, the ones that are closest together are the pair you want. All right, so here's how I'm talking about it. I'm gonna pick one from this, like 3, and one from this, 5. 3 times 5, 15. And then 4 times 7, 28. 15 and 28. Do those add to 52? They do not. All right, so that's not gonna work. Now let's try it the other way. 20 and 21. Well, 20 and 21 is 42. That's not gonna work. So I've tried 3 and 4 with 5 and 7. I have the feeling that if I try it with 1 and 35, there's not a chance in heck that it's gonna work because 3 times 35 is already over 52. 4 times 35 would have been way over 52. So there's no way I'm gonna add, two numbers and come up with something that comes up to only 52. So that one's gonna be right out at least with 3 and 4. And it would also be right out with 2 and 6. So let's try 2 and 6 and 5 and 7 instead. All right, 10 and 42. Well, 2 times 5, 10, 6 times 7, 42. Sure enough, that came out to 52. We found our pairing. So what I usually do is I connect up physically with a line the ones that I just said we were gonna pair up. Now, when I go back over there to put them in, the 2 and the 6 are what are going in for the single interline, the 12. So I'm gonna fill those in, 2, 6. Now, 2 is connected to 5. 2 is connected to 5. 6 was connected to 7. I really should have those red so that it matches. Now it looks a little better. All right, so now fill it in just to be sure you did it right. 42x, 10x, that gives me 52x. And sure enough, that is exactly what I was shooting for. And that's how I do these problems. I just work my way through them until I get to the answer I'm looking for. It takes time. And some people will get these really fast, other people, it takes them a long time. It's kind of like a puzzle. Some people are really good at puzzles, others hate them. But we still need to be able to do this because it leads to so many other math advances and simplifications that you really need to know how to do this, especially if you're going on beyond high school. This is definitely necessary to get out of high school. All right, here's our next example. Now, let's talk briefly about this one before we get much further. We know we've got two parentheses, a plus and a plus, x and x. We know we have to have pairs to give us 28, and we know we have to have pairs to give us 72. Now, there's a lot of options in these two setups. One thing that I like to do when I'm thinking about this is, if the middle term is odd, I want you to think about that for a minute. I'm eventually going to connect these up with multiplication and then add the results. If I multiply, let's think of evens and odds. If I multiply an even number times an even number, I'm going to get an even number. If I multiply an even times an odd, I'm still going to get an even number. The only way I multiply and get an odd number is if they're both odd. All right. What about if they're added? How do I get evens and odds? If I add two evens, it's an even. If I add an even and an odd, oh, I get an odd that time. If I add two odds, I get an even. So whenever we're getting the results here, we want one even and one odd result. All right. Well, let's think about this for a minute. 28, 1 and 28, 2 and 14, 4 and 7.
Could I have your attention, please? This is just to advise all employees, tomorrow morning when you get to work, we will be set up in the cafeteria to pick up your packets that will include paperwork to be filled out. So please bring a pen with you. Also, the calendar, schedules, and whatnot will be in the folders at that time. So whenever you get to school tomorrow morning, please come into the cafeteria and go to the appropriate desk to pick up your paperwork. Please bring your own pen. Thank you.
And that's what we get to put up with on a daily basis. But let's ignore that and get back to the work. 72, 1 and 72, 2 and 36, 3 and 24, 4 and 18, 6 and 12, and let's see, that'd be 9 times 8. Should have put the 8 on the other side. All right. Now, if I were to put an even here and an even here, remember, we said when we multiply an even times either an even or an odd, the result is going to be an even. Even. So if I use a pair where both of them are even, I'm going to end up with an even answer, not an odd. So that leads me to the thought process that anytime my middle term is even, I can eliminate all of the pairs where both of them are even. That leads me to having about half the number, oh, I forgot about that one, half of the options. So that can really drastically alter the number of options and the number of times you have to try something before you get something that works. So now let's try that pointing method again. We're trying to come up with 95. Let's see. Let's try 4 and 8, 32. 9 and 7, let's see, 63. Yeah, I can do it. And I add that up, that's 95. That's the right one. And it came the first time. Now, I probably should have done 36 and 56 and found, oh, nope, that doesn't work. But we got the right one the first time. 4 and 7. And then 7 matched up with the 9, 8 with the 4. So 4 and 8, 7 and 9 with 63x and 32x. That gives us our 95x. And there is our answer for that problem. All right, let's check out. Give these two a try on your own. See what you can do with it. And I'll come back and put the answers up so that you can see how they're done. Make sure you pause that video. All right, back to it. I'm gonna try this one. I know I'm gonna have to have something times x, plus and plus, and a pair to multiply to give me 15. Well, 2x squared, there's only one option, 2 and 1, and because they're both plus, it doesn't really matter whether I put the 2 first or 1 first, but 2 and 1. 15, 1 and 15, and 3 and 5 are our options. So I'm gonna plug in, let's see, 3 and 5 just to try it. 3, 5, 10x, 3x. Sure enough, it comes out to 13x, and that's just what I wanted. And so there's my answer. By the way, this stuff, that's not the answer. In fact, if I erased all of those lines and all that, I can't quite get the green lines, they're a little tight there. That's my answer, 2x plus 3, 1x plus 5. And that's how I'm gonna read the answers. 2x plus 3, 1x plus 5. You don't have to read the parentheses, you don't have to say times. We know that's what's going on there when we read off these answers. All right, let's take a look over here. Well, I've got an odd middle term. So I know, I probably should have put those signs in a little more separately. Like so, a plus and a minus. All right, so I have an odd middle term, and that means I can't use 4 and 4, or 2 and 8. So I have to use 1 and 16. And I don't know which one's gonna go where, but I'm gonna say that the 16's here and the 1's here, just try it.